Okay, firstly, go ahead and excuse my extremely messy hobby table at the moment, but we're gonna go over a video just talking about this Scx24, which is a crawler, and just some things to keep in mind if you're looking for performance over detail and looks and things. So this is started out as a deadbolt, as you might be able to tell. It's got some modifications, and we'll go over those as well as some things to look for and improving performance and what this thing has on it to improve its performance. So we'll go ahead and start with the top. So as you can tell, this shell has been heavily modified, both moving different things. You can see the rear was cut out at one point to mount it as low as possible without hitting the diff cover. It's been chopped up to accommodate larger wheels, clearing the servo and mounting it as low as possible. So with that, we'll kind of dive into center of gravity, which is why this body is mounted so low. Ideally, when we're doing crawling, one of the key factors in performance is having a low center of gravity, and we do that by pretty much mounting everything as low as possible and reducing as much weight as we can up top. So we'll go ahead and take this off. This is just held on by two magnets, and sometimes I'll put zip ties through the rear bumper here to give it that kind of action. So taking a look at this guy, you'll see it's got the new Endura MB100 ESC, and then I've got my Radio Master receiver here. So this is actually a new setup that I just did last night. But anyway, we'll get into that a little bit later. So looking at the truck, you can see that everything is mounted pretty low, and tried to get things as low as possible. The heavier things, namely like the battery, as low as possible. Receiver kind of as low as possible. I mean, not really, but as low as I could while keeping it centralized. I was thinking about putting it on one of these, but these are pretty small sliders and it didn't fit super well. But everything still works pretty well for what it is. So center of gravity. When we'll talk about unsprung weight versus sprung weight. So keeping it in the idea of keeping everything low, it's good to have weight as low as possible. So we can see like these, what is it? I guess like a hub, as well as C-hub. These links here are as low as possible. You know, they're on the axle. So when they're on the axle, that means they're not sprung. And what sprung means is they move, the weight moves. So as you can see, as the things above the shocks move and shift, these things down here do not. So that's your servo mount, all of your axle, all these things, they all stay planted, while the rest of everything else above, which is sprung, can move and shift dynamically, which will change your weight bias dynamically. So getting one early goal is to pretty much get as much weight as you can down low, and keeping everything that's sprung up top as low as possible as well. And that's going to help keep that center of gravity as low as possible and give you the best performance on inclines and things like that. So let's see. We'll jump more into the specifics of the build in a bit. Weight bias is another big one. So a general rule of thumb is to have 60% weight up front, 40% in the rear to give it a front weight bias. So if it's climbing over something, you want the front to come down to have traction to pull it up and over, and at inclines and things, you wanna keep the front planted. If the front is not planted, you will roll back, and that's not what we want, of course. We want to go up hills and things like that. So let's see. So yeah, 60-40 general rule of thumb, and that's just, you know, if you get high centered or anything like that, where your skid plate, this thing is getting stuck on something, you want the front to come down so that you can get traction and pull it over. So some quick things we'll talk about real quick is the wheels. So I think there's really no other choice, at least for me, in my opinion, other than the brass wheels, which are very heavy. And that gives you a lot of low weight that will help, you know, get that center of gravity down to keep the truck planted to your surface. So I think these are probably your biggest upgrade out of the box. Some people will talk about rotational mass and overworking the motor or the ESC. I don't put any stock in any of that. I've never had motors on 10th scale or otherwise have any issues with heavy wheels. And the performance that they give is just astronomical because these weigh so much and they're so low that it really makes a dramatic difference to your center of gravity, which translates to a dramatic increase in performance on inclines. So in talking about keeping the 60-40, and specific to wheels, beadlocks have rings within them, right, which the wheels clamp into, and then the outers, you know, squeeze onto them. So I keep brass rings in the front for additional front weight bias and aluminum in the rear to reduce the rear weight. And again, that's just to keep the front coming down. So if you have too much weight in the rear and it balances out, you know, if you get high centered, you might be doing this. And again, high centered being dragging your skid plate on an obstacle or something where your wheels are bobbling like this. Whereas if you have proper front weight bias, you'll come down and be able to pull yourself over. So yeah, brass rings and the brass beadlocks, aluminum rings and the rear ones for me. And that's to help keep this front weight bias. We'll go over some more things. So I believe these have the Endura +4 axles, which are CVDs. And a CVD is like a coupling that allows the turn radius, I believe, to be a little bit better or a little bit smoother when you're turning sharp. So those are a good upgrade. I believe I got these outer hubs with those, which are extended, and they use these little brass nuts that I can't show you, but they're about that long, that go through the brass hub there and connect to the axle. These are the C-hubs. They are also brass. You can probably tell that this crosslink, or what is that, tie rod, is also brass. This is brass. The servo is sitting also on a OGRC brass servo mount. So all these things are contributing to keep that front weight bias intact, which is, yeah, again, really good to try to achieve for performance. Looking under the truck, we'll see we've got some stainless steel links. I do like plastic links because I think they slide over rocks and obstacles better, but these are kind of, stainless steel is better because it's better than, say, like aluminum or brass. Aluminum soft, brass is also soft, so that can get stuck on rocks and things like that, whereas stainless steel is a little bit harder and it will go over the rocks a little bit better. Skid plate, I like to keep mine plastic. You can see I filed off the little scale hump thing to make it flat. I don't like that these link eyelets protrude from the skid plate. So if I had an option to get one that didn't do that, I'd probably do that, but this is kind of a low budget thing, even though it doesn't look like it. So past that, we've got just the stock plastic links up front and in the rear, and that reduces a little bit of weight up top, as well as I don't think more metal is really necessary up there. One thing you'll notice is that I have longer links up front than I do the rear, and I can't remember exactly which size links I'm using. It's been too long, but these are longer than the rears, and the reason for that is pretty simple. You don't see a lot of people do it, but this goes back to high centering, right? Where if my skid plate is, say, centered right here, I'm going to have less bias up here, whereas the further back the skid plate is, the more front weight bias there's going to be. So by having the longer links up front, gives it a little more of an ability to topple over to get front traction. And you can probably tell that I also run a small LiPo flat battery up here as well, which also helps that front weight bias as well as low center of gravity. So let's see. Yeah, I kind of mounted the CSC up over the top of this just with a piece of Lexan here, again, to try to keep that front weight bias. This is a little higher than I'd prefer, but this piece of Lexan goes under this cross piece that holds my magnets. But it fits in there pretty snug, pretty good. It can't come out. It's kind of a pain to replace batteries because I have to take this section out by flexing one of these towers here. But that's the way I like it set up, to keep this as low as possible and try to keep performance as high as it can be. On the rear, let's see. So in the rear, I don't have any special hubs or anything in the rear. There is an axle extender, so I believe these are 4mm in the rear also. That's just, it's gonna be kind of hard to see, but there's a small brass Injora extender that kind of keeps these relatively close. The rear might even be a tiny bit wider than the front. Another thing you'll see is the link, what is it? I can't remember the term, but the thing that connects the rear links here is also brass. So a couple things on that, which are a little hard to explain. You'll have to kind of play with it because it has to do with your weight bias and how it works with the height of your center of gravity and some other stuff. But essentially, this gives you more mounting options for your top links, which can change your link geometry. And if you get enough, usually when a vehicle takes off to accelerate, it will squat as it's going forward and the weight transfers. So it will do, say, that. Whereas if you get enough anti-squat, which again is that geometry between the links, the rear will actually raise as it's going. And this piece offers some tuning to play with that. I might have these links higher had I not broken off and stripped some screws and that thing. But this is also a piece of brass that is attached to the axle. So that's unsprung weight. And I needed a little rear weight bias to try to keep things balanced. So it worked out pretty good. Diff covers, I just use the stock ones. Axles, I use the stock ones as well. Again, with plastic, I think it just goes over things a little bit better, a little bit smoother. and I didn't really need the weight to try to get my front weight bias where I wanted it to be. So I left those there. You could put on metal axles, but again, it might drag or be a little bit less a little bit more resistant to going over certain obstacles and rocks and things. But that would also lower your center of gravity substantially if you've got more weight higher, which could improve your ability to climb things and stuff. Keep the truck planted. So let's see, I do use a rear bumper. I like this in the 10th scale and on this, and that's simply, if I'm going to roll backwards, it will generally give me an opportunity, if I'm driving correctly, to correct myself and reverse instead of rolling backwards. Let's see. Another big upgrade for performance that is kind of an unseen one is overdrive gears. So what overdrive gears do is they make the tires turn at different rates. So generally, having your front tires spinning quicker than your rear tires will help with performance. And it does that by giving this more pull, so it's actually kind of dragging your rear tires. When you're at an incline, your weight transfers downward away from these, which takes traction away. So having these spinning a little bit faster than your rears can help it have more opportunity to grip and pull the truck up and over, which is good. Highly recommend that one. I can't remember what gears are in here, but I know there's some transmissions that can do it and things, but again, this is not a super high dollar build. It is a good performer though. Let's see, what else is there to this one? I guess I'll just say, so yeah, this thing did a 64-degree incline with the body in this current configuration. Prior to installing the ESC and receiver, we used the V1 electronics, and I actually put it on the same right in here, which came up and through the body, so it protruded out here a little bit. There's a ton more wires now with an actual receiver, but I wanted to use a different receiver and try out the new ESC. So slow crawl on this thing is really good, by the way. You might see a video of that on there somewhere if you search my name. But let's talk about shocks real quick. So shocks and flex. I know flex is a really hot topic with a lot of people, and they like to show the vehicle with one wheel, all the way up and over. I don't particularly like that personally. I find it a lot of the times it will get me into trouble more often than not. Usually when you've got that much flex, you can flex your vehicle into a position where your weight can shift enough to roll the truck over, which is not ideal. I like to keep everything nice and low. These are cheap Endura spring shocks, configured right now with these ones as contracting and these ones extending. So there's spring here, and there is, if I can even, let's see, as the truck twists, these extend out and retract, and that's done by having the springs that come with them under the piston that's inside, whereas to extend, they've got the spring over the piston. And I guess we can talk about that too. So when you're going up a steep incline, so right now you can see where the shocks are. So a lot of the times we talked about center of gravity and stuff like that, and a little bit about weight transfer, not a lot. So weight transfer, when you're going up, your weight is transferring down. So you can have 60% up here and 40 here, but if you're up like this, it's 100%. It's going to be going straight down. So that's why you have affected traction when you're going vertical. As your weight transfers down, you've got less weight on your front tires and you're going to have less traction. So when weight transfers and you don't have shocks that are constricting or contracting, whatever you want to call it, what'll happen is those shocks will extend outward and that weight will transfer outward. And when that weight transfers outward, that's what causes you to tip over. So by having these contracting by default, as the truck unloads the weight from here backwards, the springs and the shocks are holding this to the surface, which is the other direction, rather than the shocks, like let's say, sorry, it's kind of hard to explain. I'm sure everybody knows this, but just for people who don't, if there was a spring in here, the spring is of course trying to push the shocks outward against the weight. But as you go up and the weight transfers away from that, it's going to cause the springs to unload. And generally that motion of unloading is what will change the weight enough outwards to push the vehicle over if the center of gravity is too high for the incline. So this kind of prevents that. I don't run it a lot. If you have, and that's another thing, like when you've got shocks that do a bunch of flex and they have a bunch of shock extension, this is where they'll extend a lot that way. And once this weight and all this weight transfers out, that's when you roll over. That's why I don't like those. But that's easily aided. A lot of people use the rubber bands on their regular shocks, which will help keep them compressed. And that's a fine way to do it. I might even do that myself sometime. I just have these were inexpensive and kind of what I have, so work with what I have as much as I can. So that's that. Yeah. Let's see, what else? I think that's about it. The big thing on going up, I mean, when you're going down, I guess we'll talk about when you're going up also. If you see these angles this angle of the shock is not giving a ton of extension, and it's a pretty short shock, so there's not a ton of flex, but because the center of gravity is so low, it doesn't need a ton of flex to be able to side hill or anything like that, because again, that flex can push this over and cause you to roll over. But if we look at the angle of the rear ones, at this angle, they're straight up and down. So as we go, you can see that that's straight up and down. So when that weight transfers back, it's going to be fighting those shocks. But having these extending is going to resist that. Whereas if we had them sucked down like this, sometimes that will change the angle of your chassis and the weight. So if we have the front wheels, at this angle versus this, you can see how that's changing the where all that weight is. And sometimes if that gets too far over, that can cause you to flip. Whereas this is kind of helping the truck stay at a higher angle, even though the truck's on an incline. So that's kind of why I kind of like to keep those. Usually I'll also reverse these. There's not a ton of extension again. So while this will extend out further, it'll give a little bit higher ride height, so a little bit more clearance, that much clearance, which will make it a little bit easier to get up and over obstacles. It'll hurt the incline a little bit, but generally not enough to make a big difference, in my opinion, or for what I do. Let's see. One more thing, I guess we'll talk about tires real quick. So these tires make a big deal. Obviously, this is what touches the surface that you're crawling on. So having grip has a lot to do with what tires you choose. I just got these ones, which are the OGRC Comp Pros. The bigger the tire, the taller your vehicle is going to be, and of course that raises your center of gravity. But taller tires also gives you, a higher, more clearance to get it up and over things as well. So it's kind of a double-edged sword. If I were to run much smaller tires, it'd give me a lot lower center of gravity, and I can crawl steeper, but I wouldn't be able to make it over as many obstacles. So I like these ones. These are 63 millimeter, which is pretty big, but they've been performing really great. And like I said, been able to get a 64-degree incline with this. That has, which is pretty impressive, I believe. Impressive for me anyway. And just real quick, we'll talk about these tires specifically. Well, tires in general. So these tires came with, they call them dual stage foams. And really what that translated to was this ring being within the foams, which is very stiff. And the idea is that you don't want your tire to roll over when you're side hilling, because if it flops over, then again, that moment of weight transfer can cause your vehicle to tip over. For me, I like to run really soft foams, and I'll show you the reason, which is pretty demonstrable here. So if you look at this tire right now, we can see that there's about 3 pins on the table. So this tire is kind of flat. If we look at the rear, we've got probably 2, maybe 2.5. So that front weight bias is squashing this tire down, and what that does is the more area you've got on the surface, of course, the more traction you're going to have and the better chance you're going to have to go up and over obstacles, or basically that's it. So running soft foams obviously achieves this better. Weight bias and things helps us out. But with these tires in particular, I took these out and just ran the pretty soft foams that they had in them. I don't believe this is too soft for me. And in terms of sidewalling and things like that, just to give you an idea, this is if I'm sidewalling or if I'm climbing something with it sideways, this isn't terribly bad for me. Like, I'm okay with this. So it's not completely folded over, even with the weight, fully on these tires. So we can get a front shot. So that's about what it looks like. This might not be okay for some people. I'm okay with it personally. I think this gets the lugs in a little bit and kind of flattens out a little bit, keeps the traction, and I'm not worried about that at all. So I just ran so they're slightly, it's kind of a pain to mount them up because the inner ring is a little bit, because it's expecting you to have this. You got to get it set in there right with the beadlock rings. But yeah, I ran it the other day at our local mini course, and it did well. It kept up with some other trucks that are really capable, and I left it in this configuration, and it was still making it up and over obstacles and stuff. If I'm having any issues with getting over stuff, you kind of give it some gas, and since this whole half is longer, it's more than half, is longer than the rest of it. Usually, as long as I can get up onto that skid plate with the weight bias, it's gonna topple over and get traction in the front and get going. Yeah, let's see, I think, holy shit, 30 minutes. Pretty sure nobody's listening at this point, and I think that's about all I've got. This is the Endura chassis. These are just some little skid plates from our design. Not fully necessary, but I wanted some. You can make them out of Lexan. Really like the servo, very smooth, good power. Getting creative with things, like fitting this battery up here with the length of the links up there. I think this is a pretty big performance thing that gets that weight, the battery weight, all the way low and all the way forward, pretty much as low as you can, which helps out big time. Might try, this will do 3S batteries, might try exploring that in the future, which I'll have to modify the setup. But yeah, this is pretty much it. Little flat packs fit nice in here, this little Endura chassis. I guess I can show you keeping the, I also have a metal drive shaft up front. And this is solely for weight bias. You'll see I have the plastic one stock in the back. I don't have any problem with plastic drive shafts personally. But yeah, this helps out with weight bias a little bit. If you're getting metal ones of these, make sure it has the D-shape coupling and isn't using set screws like this one. Yeah, I think this one is. Anyway, to hold things together, because then you're putting all your force on a set screw versus an entire shaft if the shaft has the D cut out. Yeah, I think that's about it. Yeah, we went over the magnets on that. Those little shafts that came with the Endura thing are what's holding that in. The plate, carbon fiber plate that came with the Endura kit is just stacked onto the motor with some double-sided tape, as well as, you can't really see it, but on the ledge of the transmission there. Holding the ESC, I went over it. It's a piece of Lexan that I just bent to fit over this battery. It has a notch in it, which hooks up to a notch on the transmission, and it's double-sided sticky tape to the bottom of this. Let's see if I can do this with one hand. Probably not. I'll just set it down real quick. This is just to show you exactly what we're working with. Okay, so this comes out, and my whole ESC comes out with it, so you can better kind of see. I need to redo these because I was just experimenting. So I'll have a longer strip of double-sided sticky tape. You can see the tape holding the ESC on. That's the notch that sits in that transmission notch right there. And this just comes out. And I put that back in the towers, and that's it. All right, well, hope that helps somebody with either fabricating or trying to get more performance on their Scx24 or any other crawler. There's a lot of general stuff in there. I guess the high clearance links I didn't touch on, but high clearance links just give you more clearance basically to slide over obstacles, and again get that front to tip down easier and get you to where your skid plate is skidding over things. And we went over the links and everything being longer up here and why we did that. I guess I could say that moves your motor and transmission back that way a little bit. So having proper add-ons to accommodate that and try to get that 60/40 is necessary to do that. of course, that allowed me to run my battery all the way up front and low. So that was a big contributing factor also to running it this way. All right, that's it for now. Thanks for watching. Hope you learned something. Yeah, if you have any questions, let me know. I'm kind of slow to respond on YouTube, but hope this helps somebody.